Dear viewers, you are my greatest inspiration. You have supported me all these years. Your kind words of appreciation motivate me to keep making more videos. Welcome to my quantum physics video lesson series. This video series is a full package, or information bank. The viewers are advised, and encouraged, to watch each and every video lesson in this video series, in order to perceive the background concept. These 7 distinct video lesson episodes are a thought-provoking journey through the subatomic world. This particular video here offers an exclusive lecture on the key subtopic, Isaac Newton versus Christiaan Huygens. Is light really wave? Or particle? Have you often pondered over how quantum physics is rather philosophy than mathematical derivation? Philosophy? Or physics? Well, that's what we say about cosmology, right? The esoteric dispute over wave-particle duality. When and how did the shift in balance of conception ensue? Ancient views about the nature of light. Wave nature versus particle nature of light, and electromagnetic wave, is an often cited century-old esoteric debate. Isaac Newton's corpuscular view continued to receive unanimous support, as the community of erudite scholars, and academicians back then, either surmised, or conceded, as revealed in the publication excerpts. Eventually the substantial transformation, a sea change, transpired. By the 17th century, Christiaan Huygens, and then, since the 19th century, Thomas Young, and Arthur Compton, turned out to be the 3 veritable instigators of the tilt in the balance of conception, which emphatically shifted the description of light towards one side or the other. Later on, Louis de Broglie, who spoke so vehemently of matter wave, played a key role in unraveling the mystery. Sir Isaac Newton, the most enigmatic supreme genius in the history of science, is highly regarded for his laws of motion, gravitation, and nature of white light. Christiaan Huygens was the first to describe light as traveling in waves, proposed in 1678, whilst Isaac Newton thought light was composed of tiny particles. Christiaan Huygens brought about an entire new perspective of optics. According to Huygens' wave model of light, every point, on a wavefront, is itself source of spherical wavelets. The sum of those spherical wavelets forms the wavefront. Huygens' model of light, which provided a new understanding of optics, assumes light behaves as a longitudinal wave, characterized by oscillation, crests, troughs, and amplitude. He further proposed that a primary wavefront can be perceived as infinite number of points, each point generating a secondary wavelet in a spherical manner. The interference of these secondary wavelets creates wavefronts of varying shapes and direction. Back then, this model was able to explain most of the properties of light, including refraction, reflection, as well as diffraction. By 1770, two apparently incompatible theories of light were in competition. Christiaan Huygens formulated wave theory of light. The undulatory theory that light is transmitted as waves, was proposed by Huygens in 1678, and published in 1690. Newton versus Huygens. Newton was interested in light, from very early on in his career. For various reasons he favored the particle theory of light, which rationalizes rectilinear propagation of light. However, Huygens supported wave theory of light, which is by far his most important contribution to science. He demonstrated wave interference, arguing that wave theory supports reflection and refraction. In the 17th century, before the notion of the photon was accepted, or even introduced, the wave nature of light was widely accepted. Following the proposed wave theory of light, which was one of Christiaan Huygens' key accomplishments. Now, hold on a minute, buckle up. Ready to hear something rather dramatic? Even though Newton's corpuscular model of light failed to account for color, polarization, interference, and diffraction of light, his theory generally prevailed. On the other hand, despite Huygens' commendable accomplishments, Huygens' principle wasn't even indisputably approved, or formally accepted, until Thomas Young's double-slit experiment turned up as the first firm support, in favor of Huygens' wave model of light. Curious and eager to learn more? Watch my elaborate video lesson on Thomas Young's ingenious double-slit experiment, how it corroborated Huygens' model, and contradicted Newton's hypothesis. Ready lecture notes and study materials are available on request. Please use the comments section below for further academic discussions. Viewers' suggestions and ideas of new video lesson topics are gratefully appreciated. Stay tuned for more uploads. Please remember to like, subscribe, share,